Swayam Prabha. Digital India. Educated India.
Now we'll look at how to carry out mesh analysis when we have voltage controlled sources. That is a voltage controlled voltage source or a voltage controlled current source. Now if you recall, when we had nodal analysis with current controlled sources, the controlling current was restricted to be through resistors. Okay. Now similarly, in this case, when we have mesh analysis with voltage controlled sources, we restrict the controlling voltage is restricted to be across a resistor. Okay. Now I'll emphasize again, it's not that when the controlling voltage is elsewhere, let's say across a current source, you cannot analyze the circuit. You definitely can. What we want to do is to carry out mesh analysis without introducing auxiliary variables. Okay. If you have the controlling voltage across a current source, you have to introduce an auxiliary variable for that voltage drop. Now we don't want to get into that. So we have made these restrictions just to tackle only the simple cases. Okay. And that's the same reason why we restricted the controlling current in nodal analysis to be only across a resistor. Okay. If the controlling voltage is across a resistor, clearly it can be written in terms of the current through the resistor. So it can be treated analogously to current controlled sources. Okay, that's why we introduced this simplification. So let me take this circuit, and I have defined this voltage Vx across R13, and in the second mesh, instead of a fixed voltage source in our original circuit, I have a voltage controlled voltage source KVx. Okay. Now we know that Vx is R13 times the current through R13, which is I1 minus I3. So this voltage source can instead be written as KR13 times I1 minus I3. Okay. Now clearly, instead of thinking of this voltage source as K times the voltage Vx, you can always think of it as KR13 times some controlling current I1 minus I3. Okay. So with this rewriting of the expression for the voltage source, this becomes analogous to a current controlled voltage source, which we have already studied. Okay. So what I suggest you do is, please write down the mesh analysis equations for this circuit. Like I said, this is analogous to having a current controlled voltage source. Go back to that case and see how we did that, and write down the three mesh equations. Because we don't have any current sources, we can write the three mesh equations without any problem. Now I'm going to put down the answer, the mesh analysis equations, but please carry it out yourself and compare it to the answer that I gave. Okay, so that way you will have better practice of doing mesh analysis. These are the mesh equations for the circuit I showed. Now the control source appears here and there in the equations for the second mesh, as you expect, because the controlling source is part of only the second mesh. I have written it as R times I, the unknown vector, being equal to the independent voltage source vector. The important thing is that this R is asymmetric now. Okay. Now let me consider a case with a voltage controlled current source. The voltage controlled current source is here, right? And its current is defined as Gm times Vx. And Vx is across this resistor R13. So Vx can be written as current through R13, which is I1 minus I3 times R13. So this control source can be rewritten as Gm R13 times I1 minus I3. With this restatement, you see that there is no difference between having a voltage controlled current source or a current controlled current source. Okay, so this is analogous to having a current controlled current source. This is because the controlling voltage is across a resistor, so it is proportional to the current through the resistor. So whether you think of this as a voltage controlled current source or a current controlled current source, you will have exactly the same set of equations. So again, because we've already treated the current controlled current source case, please write the mesh equations for this by yourself and compare it to what I put down. Okay. So these are the mesh equations. We have to form a super mesh because we have a current source and we don't know the voltage drop across it. So we form a super mesh by combining meshes 1 and 2 and mesh 3, business as usual. Okay, no change from before. And finally we have the voltage controlled current source, and this is analogous to a current controlled current source with K replaced by Gm R13. Okay, so that's all that's there to it. And again, you see that the resistance matrix here is hybrid. It has both quantities with dimensions of resistance in the first two rows and dimensionless quantities in the third row. Okay. Now I went through mesh analysis a little quickly because we have studied nodal analysis extensively, and you can make analogies between each case of mesh analysis and some particular case of nodal analysis. Okay. So please study these correspondences as well so that you can learn both nodal analysis and mesh analysis really well.